we want to solve for A, solve for the unknown A if we're given all the other information. So we're given surface area as X, which we're told is 939. That's the total surface area of this prism. We're told that Y, the dimension Y is equal to 14, and we want to solve for A. So talk to me about this. How would we set this up? And let me, before I throw it out there, let me say one more thing, I guess. We always want to start with a formula, right? If we want to solve for A, we've got to have some equation I can use to isolate A. And that equation is going to come from the surface area formula. Yes, sir?
The formula for surface area of right prisms.
So the surface area of a prism, good. What is that? And you're going to want to know these. In fact, I think we need to have a quiz over these, just to force you to memorize them. Not today, not tomorrow, but like maybe Sunday. How's that? Or I mean Monday, not Sunday. You guys take Sunday off. Monday. Yeah. So what's the surface area of a prism?
2B plus pH.
That's it. Okay. Now, what's that mean? Think about this. The prism has some characteristics that are always going to be the same. If I take a prism, remember, we talked about it in terms of setting it on a coffee table. If I want to take the prism and set it down on the coffee table, I want to set it on its base. The base is going to be the surface that's, when it sits flat, there's going to be a surface above it that's also flat, right? So what would the base have to be in this case? If I want the two bases, the two faces that we call the bases on this thing, have to be congruent and they have to be parallel. What do you think? Flip it. Okay, meaning flip it down like that? Yeah, good. So what would the shape be of the base then? Triangle. Yeah. The triangles would have to be the bases this time. Everybody agree with that? Okay. So now if I want to pull this thing apart into pieces, if I've got, what would the net look like? If I were to unfold this thing, now, if that's Y and I've got these little congruence marks, what does that mean? Okay, good. So this one would also be Y, right? So what if let's cut this thing along these sides. How about if we cut it, we're going to cut it there. And where else do we have to cut it? Well, we're going to cut it there, and I guess there, how about? And there. Cut those edges, and then this one back here. If I did that and I unfolded it, what's it going to look like? You want to draw it? What do you think?
3 rectangles.
Okay.
All in a line.
Okay, so I'd have something like this. There's one rectangle, there's another rectangle. And then I've got, those would be the bottom and the left side. Everybody agree? If I push that, if I take this flap and just fold it down, right, then this guy is going to become this guy. And then this great big rectangle is going to fold down like that. Maybe look something like that.
And then have the right triangles on the outsides of the middle.
Okay. Those are going to fold down like this. So there's the net of that shape if we unfold it. We see that? And which sides would be red? Then wouldn't this side be red? No, that edge be red, that edge be red. Like that? Everybody see that? Okay. All right, so now if I wanted to add these things up, let's see if we can reconcile what this net looks like with that surface area equation. What about the 2B part? We said the bases were the triangles, right? So then isn't this, the area of this triangle is just B, and the area of that triangle is B, right? That's what we're calling the capital B, the area of the base. And there are 2 of those to add up, right? What about this part right here? How in the world does this big triangle that's left over then, once we've accounted for the triangular bases, how is that blue rectangle going to have dimensions p times h? What is the height again of this thing? What's the height of a prism? What do you think? Oh, somebody got an idea? How do you define the height of a prism? Height of a prism. What do we mean by the height of a prism? If I set it on the coffee table, I've got the base that's sitting on the coffee table and another base above it. Yeah, right. The perpendicular distance between those bases. How far is the top triangular base above the bottom triangular base, right? In this case, the triangles. So what dimension on that thing is going to be the height? If I look at our prism on the left up here, which measurement or which dimension corresponds to the height? A, yeah, right? The distance between the, does that make sense? Okay, so that works out okay. So this is A, right there, right? Doesn't that make sense? If I unfold this thing, I'm forgetting about the triangles. If I unfold the rectangles, that the height of that great big long rectangle is the same as the height of the prism. We okay with that? Now, how in the world, that's taken care of, so that's h. How in the world is that distance p, though? What do you think? What does p stand for? What does capital P mean in that equation? Perimeter of the base. Yeah, the distance around the base. I need a new color. Let's, what are we going to do here? Green. Okay, so what if I were to draw a green line around the perimeter of the base? When I unfold this thing, what's that going to look like? Isn't it just that distance right there? Everybody see that? Right, when I unfold this guy, when I flop those sides down, I get this long green line that corresponds to the perimeter. Does that make sense now? If you see it that way? Right? There's the perimeter, there's the height. So that's how we get our formula. Okay? All right, so now we got to plug in the specifics. We've got our formula. Now we want to plug in the stuff that's given to us into this formula, which is going to give us the equation that will allow us to solve for A, right? Okay, are all the phones and stuff away, please? Okay, so now what's that going to look like? I take my formula up here. What number do I plug in for surface area?
X.
Yeah, X, which it tells us is 939, right? So this number, let's just do this. Copy that. Okay, let's plug in numbers. So S becomes 939. What about B?
28.
How'd you get 28?
14.
Okay, now hang on. No, but it's the area of the base, right? So here's the base. The base is this triangle that's 14 across and 14 high. What's the formula for the area of a triangle? 1/2 base times height. Okay. So if I'm looking at the green triangle up here, what's the base of the green triangle? Okay, now remember, we're talking about the base of the triangle now, not the prism, right? We're just trying to calculate the area of this triangle. So 1/2 of 14 times 14 is going to be the area of that triangle. Agreed? Okay, so 1/2 times 14, well, hang on, let's set it that way. We know 1/2 of 14 is 7, don't we? So we get 7 times 14 is what we were calling B. That's the area of one of the triangles. So I need a 2 out front, right? Are you with me so far? Okay. Plus, what about perimeter? Perimeter's a little tough. The perimeter of that triangle is the distance around it. Well, if I start there and I travel down that side and over across and then back up there, that's 14 plus 14 plus what? How am I going to get that diagonal distance? I'm going to have to use Pythagorean theorem, aren't I? Good, I've got a right triangle here. And so I know that a squared plus b squared equals c squared. C is always the hypotenuse, right? So let's scoot down the page and do that calculation. So here's my triangle. (14, 14), and this is the hypotenuse. So let's just call that, we'll call it x. How about? Yeah, we don't know what that is yet. But I know from the Pythagorean theorem that x squared must equal 14 squared plus 14 squared. Everybody agree? Okay. And that's 196 plus 196, which is 392. So we can turn that into a number. Now, how do I solve for x? Square root. Sure. So x is equal to the square root of 392. Okay. Square root of 392 is just a number, but if I turn it into a decimal, it's an awkward way to write it because the decimal goes forever unless it's a perfect square, which it's not. I don't want to do that. I'd rather just leave it like that until I finally put it into my calculator. Okay. But now that we know what this distance is, the square root of 392, what's the perimeter going to be? The perimeter is just the sum of all those distances. So 14 plus 14 is what? 28. Plus this distance right here, right, which we just found was the square root of 392. Times h is a. Everybody see that? You see how we got that equation? We just plugged in the numbers for our particular prism that we're given into this formula, right? We plugged in numbers for B, we plugged in numbers for P. That's that whole thing right there, right? That sum. Notice it's in parentheses, though. It's a quantity, because that's just going to be one big number that we don't know what it is yet. And then the height was A. Oh, and let's not forget this. The surface area was given to us as 939. Right? So now all I'd have to do is solve for A algebraically. So what's that going to look like? Let me try to just grab that equation that we created. So what would I do to get that A by itself? I want to solve for A. Talk me through. This is the part where we're kind of done with the geometry now. We just want to do the algebra. What do you think?
Simplify.
Okay, let's simplify this. So by that, I guess you mean maybe we turn that into a number?
Yeah.
Okay. So we've got 939 equals 2 times 7 times 14. That's just 14 times 14. 196, if we do that math. Plus, now what about over here? This part, I really don't want to write that as a decimal. 28 plus the square root of 392 is going to be this horrible decimal. Let's not do that. Let's just leave it like that. As weird as that looks to you, because you haven't done a lot of this, that's a better way to write that number. We'll just leave it as the quantity, 28 plus the square root of 392 times A. Now, we've got a rule in algebra that we talked about earlier in the year. We've done a little bit, periodically, but we're getting into some more algebra now in this class. What's our rule for isolating a variable? If I can point to a variable in an equation, and that's the only variable, I can isolate it, right? So if I look up here, A is the only variable. There's only one of them. So what are the steps I would go through to get the A by itself? What would I do first? Remember, if we're isolating a variable, if we go back to our talks earlier in the year, we're just going to reverse order of operations. So there's the recipe for the steps we would do. We always start at the bottom and move up. First, we need to add or subtract if necessary. Is there something to add or subtract? Subtract 196. Yeah, is that what you said, Devin? Yeah. Subtract 196. Good. And if we do that, what do we get? Well, it's gone from the right side. That's good. 939 minus 196 would be, what, 743? 743 equals, now I've just got this big number, it's just a number. Okay, now what? We added and subtracted. Now next would be multiply or divide. What do you think? Yes, sir, Dylan. Say it again. You could. We could distribute the A, but that's a valid algebra step, but think what our goal is. Our goal is to get the A by itself. We want to get a single A by itself. So if I distribute, I'm actually going the wrong direction. It's legal to do, but it's not accomplishing what we want to accomplish. Yeah. Divide. Divide by what? Yeah. Good, good. Now that looks a little weird. Dividing by 28 plus the square root of 392, but it's the parentheses that really matter here. Because the 28 plus the square root of 392 are all in, that whole number is enclosed in a set of parentheses. Anytime something is in parentheses, it's a quantity, we call it. In math, we treat it like one single number, right? It's one thing. So if we divide both sides through by the quantity, 28 plus the square root of 392, look what happens. Those factors that are being multiplied, that's a number that's being multiplied by A, so it cancels top and bottom, right? And I get the A by itself. So now I finally get an answer. My answer just looks like A equals that. 743 over 28 plus the square root of 392. That's an exact answer for what A is. Probably Moodle's going to ask you to put that in as a decimal, which is fine. Once we finally get an answer, we can turn it into a decimal and round it. That's fine. But we don't want to round in the middle of the calculation. If I would have rounded, say, 28 plus the square root of 392, if I would have rounded that to a number, when I used it in this calculation, it would have thrown me off a little bit, wouldn't it? It would have accumulated some rounding errors, what we say in math. So how do we do this on a calculator? A couple good ways to do this. And, it is easier to do on a graphing calculator. There's no question about it. Oops. Okay, if I want to do this on a graphing calculator, the best way is just to put it in all at one time and push enter once. That's it. So how would I say that? On a graphing calculator, I could say 743 divided by, but because I've got more than one thing in the denominator, I have to enclose that in parentheses. So I'm dividing 743 by the whole number, right? So in parentheses, I would say 28 plus square root of 392. And then I've got to close those parentheses. So on a graphing calculator, I'd have to hit the right arrow to get out of the radical, close the parentheses, and if I hit enter, whoops, if I hit enter, that's my answer. Okay, and if we're supposed to round to two decimal places, I would just get 15.54, right? There's another way to do that too. If you don't want to do it as one big calculation, you don't have to. Excuse me. I could just figure out what the number is on the bottom, for example, on my calculator, but not round it. So I could just do 28 plus the square root of 392, hit enter, and get this number. Okay, now the calculator is only showing a certain number of decimal places, but it carries like 18. I mean, it takes it way, way out there. So what I can do on a graphing calculator then, if I want to divide 743 by that number, I can just do that. I can say 743 divided by, and I'll just hit the up arrow and go up and highlight that and hit enter, and that grabs it. Now if I hit enter, look what we get. Same exact answer we got before. Okay. There's even another way to do it. There's just an embarrassment of riches here. If I were to calculate 28 plus the square root of 392, hit enter, just like before, I can also say 743 divided by, and on the calculator, notice that right behind the negative sign it says ANS. It means answer. So if I hit second answer, what that means is it's going to pull the last answer that the calculator computed and plug it in right there. Same answer. Okay. So that's how we'd use a calculator to do this. Now, if this seems a little bit mundane, like why are we talking about calculators? I'll tell you what, honestly, I think if you were to look at the skills you take out of a geometry class, this geometry class, if you're not going to, say you don't end up being an engineer or a scientist or a mathematician or a statistician or any of that mathematical type stuff, what you will end up doing, guaranteed, in virtually any job at some point in your lives in that job, you're going to have to do big calculations like this where you've got a bunch of numbers that you've got to crunch together and get a single outcome. People are terrible at that. People make mistakes like they try to break the calculation up into little pieces, they round in the middle, and consequently they get wrong answers. This is the skill, being able to do stuff like this, that I predict most of you, all of you, will eventually use. Some of you will use other mathematical stuff, much more difficult than this, but a lot of people won't. A lot of people aren't going to use mathematics directly in their career, but they will do calculations. So this is really good practice. All right. Now, why is he doing another one? Well, we're not going to do the whole thing, but there's a good moral to this story on this one. This is a much easier problem to do than the last one. The triangle one was tough because think of the stuff we had to do. We had to, in order to calculate the surface area of this prism, we had some steps in the middle that were kind of involved some calculations also. We had to find the length of that hypotenuse, which ended up being kind of a weird number, square root of 392, right? So the triangle aspect of this prism made it a little bit harder. This rectangular prism, much, much easier, because rectangular areas and perimeters are easy to calculate, aren't they? Right? Okay, now, here's the question I've got for you, and I want you to think hard about this, because there's a principle going on here that this is kind of maybe more for people that are going to go on in math. When you get to calculus, for example, most of what you do is not learn the calculus, it's learn how to use the calculus in the best way. Because doing a problem in two different ways might result in 20 pages of work or half a page of work. And obviously, I think we all know which one we want to do. You start to see that a little bit even in geometry. If I want to calculate the surface area of this prism, there's a good way to do it, an easy way, and there's a hard way. First of all, what is the base of this? What are the bases of this prism? So y and a. So you're saying right now that what currently is, we might say, is the bottom face and the top face could be the bases. Correct. Is there another way to do it? Say it again.
Any could be bases.
Any pair of opposite faces could be bases in this case, couldn't they? Because it's a rectangular prism. If I were to flop this thing down forward, couldn't what currently is the front and the back faces, couldn't those also be bases? Right? They're going to line up vertically, aren't they? Or what currently is the left and the right, I could tip it over on its side, and those could be the bases, right? Now, whichever ones I choose is going to impact what the calculation looks like. Let's write down our formula again. We know that the surface area of the prism we said was 2 B plus PH, where capital B is the area of the base that we choose, and capital P is the perimeter. Now, what if we just leave it the way it is right now? What if we leave the top and the bottom as the bases? Okay? If we do that, look what happens to the calculations for B and P. What's the area of the bottom base? Now, let's go ahead and plug in the numbers first, too. We know that Y is actually 6. So let's just replace that with a 6. We know W is 20. So let's replace the W with a 20. And we know the whole surface area is 948. Okay? So if we were to calculate the area of the base, what would we get? It's a rectangle that's 6 by A. So what's the area? 6A, right? Isn't the area of a rectangle just length times width? Okay, everybody with me? Okay, you got to really concentrate on this. 6A. Okay, what is the perimeter? Perimeter is just the distance around, right? So that's going to be 6 plus A plus 6 plus A. And what is the perimeter of a rectangle? No, we're just adding up the distance around now. So I'm going to get 6 plus A plus 6 plus A. 2 6's and 2 A's, right? Perimeter of a rectangle is just 2 times the width plus 2 times the length. Because the ant that walks around the perimeter is going to walk the length twice and the width twice, right? Make sense? So the perimeter would be 2 times 6, that's 12, plus 2 times A, right? Everybody see that? And then the height. If we use the top and the bottom as the bases, what's the height of this prism? 20. Okay, good. So look what that calculation becomes then. If I plug in the stuff, I know S is 948 equals 6A plus the quantity 12 plus 2A times 20. We'll call that equation 1. If we choose the bottom as the base, that's what we end up with. Yes, sir?
It's 2 6A.
Oh, 2 6A, you're right. 2 times B. So that shouldn't be a 6. What should that be? 12. There you go. Good. Oops. Good. Okay? Now, what if instead, what if we choose the front face and the back face as the base? Is it going to change the total surface area? No, it's not going to change the surface area, but look what it does to the calculation. Let's switch to blue for this, our little change here. If we think of this as being the front face, right? And then the back face is the other base. What does B become? What's the area of the front face? Width times length, right? Length times width. That's 6 times 20. Isn't this just a 20? So what is that?
120.
120. Okay. What's the perimeter? If an ant walks around the surface of that base, yeah, he's going to go 6 plus 20 plus 6 plus 20. 2 times 20 plus 2 times 6. Isn't that just 52? 40 plus 12. And what's the height? Everybody see that? If this is the base, then A is now the height, isn't it? Right? Okay, now let's see if that makes a difference. When I create an equation, then I've got surface area. Right? Move up just a little bit. So there's our equation, right? I get surface area, which is 948, equals 2 times B. Well, B is 120. What's 2 times 120? 240. Plus P, which is 52, times A. Okay, now I want you to tell me, Which equation would you rather work with to solve for A? 1 or 2? Wouldn't you rather work with 2?
Yeah.
What are the steps I would go through? Okay, good. I'd subtract 240 first from both sides and then divide by 52. 2 simple steps, right? What would I have to go through to solve for A in the first one? Yikes. I'd have to distribute the 20 first, right? That's going to give me, I'm going to get what, 40A and 12A. I'm going to have to add up like terms so I get a single A term, right? And then I can start thinking about isolating the A. Everybody with me? So what's the moral of that story? If we've got something like the original situation we're in, we would rather have the unknown dimension be the height than a part of the base, wouldn't we? So if you've got a rectangular prism, you always want to orient that prism in such a way that the unknown is the height, and it makes the calculations much, much easier. Okay? It'll work either way. You can get the same answer, but I don't know. I'd rather do it the easy way. Okay? All right. All right, we got 8 minutes. Okay, let's take a quick look here. Quick look. Quick look at 12.3. We're not going to get through it. The 12.3 is kind of tricky, but I want to get you just thinking about some of the topics that come up in 12.3. Maybe we can come up with, if we really get lucky, I don't know if we'll quite make it. The goal would be if we can come up with a formula for the surface area of a pyramid, that'd be great. We probably won't get that far. Let's at least talk about what a pyramid would look like, though. Okay, here's an example of a pyramid. Notice that's quite different than a prism. A pyramid, when we talk about the base of a pyramid, that's going to be the part we sit on the coffee table so that the point at the top of the pyramid, the vertex, is going to be above the coffee table, right? So in this case, it looks like we've got a rectangular base, and we've got these 4 triangular faces that all converge at the point of the pyramid, the vertex, right? Now, if we want to talk about the pieces, then, of a pyramid, obviously the vertex is the top, the base is the flat surface we stick on the table, and all of the triangular pieces that are going to converge at that vertex we call the lateral faces. Okay? We'd say that all of the places where the lateral faces meet each other are the lateral edges, right? And then we could talk about the base edges being just the sides of the base. And there's one other piece we have to consider. Oh, one other thing too. What's the height? The height of a pyramid is just the vertical distance between the vertex and the base. So if I were to drop a ball straight down onto the coffee table or a marble or something from the vertex, it's just how far it would fall before it hits the coffee table, right? We need another measurement here, though, which is a little bit inconvenient. We didn't see this with cylinders or prisms. We need to know what's called the slant height. We've got to know what is the perpendicular distance from the vertex to one of the base edges. Okay, now why do we need that? Here's why we need that. Because when we want to calculate the area of a pyramid, think what happens if I unfold the pyramid. If I unfold the pyramid, I always end up getting something that looks kind of like a star, don't I? Right? I've got the base, and then I've got these triangles that would fold up to meet at the vertex, right? Now, if I want to find the area, the total surface area of this shape, that's the same thing as the surface area of the net that I create when I unfold it, right? Well, if I want to find the areas of these individual triangles, remember that the area formula for a triangle is half the base times the height, right? Okay, you got to really focus on this here. This one's, you're going to miss this one. This is the last topic, the last concept I want to get, and then we're good. If I pull one of those triangles off, isn't the height of the triangle, we got to calculate the areas of those triangles, isn't the height of the triangle the same thing as the slant height of the pyramid? It's not the height, is it? Right? It's different than the height of the pyramid. It's a little bit longer. Right? If I go back to this picture right here, you can see that slant height, one more. You can see that slant height is a little bit longer always than the height of the pyramid, right? Okay? The slant height is literally the height of the triangular face. If I pull it off the pyramid and set it down, it's the height of that two-dimensional triangle. Okay? So then what if I want to come up with a formula for this? If I want to come up with a formula for this, I've got to calculate the area of the base, just like before, but then I've got to add up the areas of all of those triangles, right? Everybody see that? Okay. How could I do that? Well, I can add them up one at a time. I can always add them up one at a time. But we can see here that if we start off with that calculation, the surface area is the base plus, in the last example, it was a hexagon, right, for the base. So I have 6 triangles. 6 times 1/2 the base times the height of the individual triangles. Well, what if I just forgot the 1/2 there. They forgot the 1/2. What if we pull the 1/2 out front and we combine the 6 with the b? What is 6 times b? If b is that distance, that small b is the length of one of the sides of that hexagon. Yeah, it's perimeter, isn't it? Right? That's just the perimeter around the base, right? So what I end up getting is, gosh darn it, so what I end up getting, I got to put that 1/2 in there. I left the 1/2 out. What I end up getting is b plus 1/2 p L, where L is the slant height. Okay? So there's my formula. We really need to do an example or two actually using that formula for it to sink in, and we just ran out of time today. But you could get maybe started on that assignment. If you finish 12-2 up tomorrow, you could start that one. All right.